True limb replacement requires blurring the cognitive perceptual lines between self and machine. Agency is the crucial bridge to perceiving the actions of an artificial limb as generated by self and intentional. This technique provides unique insights into the effectiveness of the cognitive perceptual communication between the human user and the machine.
This method could extend into any examination of the effects of feedback on agency, such as with myoelectric or body-powered prostheses, cortical stimulation, stroke, or even hand transplants.
Demonstrating this procedure is Dylan Beckler and Zachary Thumser, research engineers in our laboratory.
Escort the participant into the testing room and have them sit in front of a monitor. Begin by generating a hand kinesthetic percept through the participant's neural machine interface, or NMI, and capture the kinematics of the perceived motion by having the participant demonstrate what they feel using their intact hand. Use a virtual hand or prosthesis simulation to reproduce the kinematics of the movement percept. Next, set up hardware to capture the intentional hand movement control signals from the participant's NMI. Map this control signal to the activity of the virtual prosthesis. Then, create a master control program that coordinates the acquisition of the NMI control signal, the movement of the virtual prosthesis, and the generation of kinesthetic NMI feedback in real time. Display the virtual prosthesis on the monitor and adjust its size and location so that it is positioned congruently with the location of their missing limb. Then, render objects such as floating balls in the